Welcome back to Code Warehouse. Today's LeetCode DCC question is maximum odd binary number. You are given a Welcome back to Code Warehouse. Today's LeetCode DCC question is maximum odd binary number. Let's read the problem statement. You are given a binary string S that contains at least one ones. You have to rearrange the bits in such a way that the resulting binary number is the maximum odd binary number that can be created from this combination. Basically, we have given a string which contains 0 ones, and we have to rearrange this string in such a way that we get the maximum odd binary number. Let's take an example and understand the question. So if we take example 1, the input is 0, 1 and 0. So we have to rearrange this 0, 1, 0 in such a way that we get the maximum odd binary number. So if we see the possible combination of this are 010 is 001, 010, 100. If we write the decimal value of 100, it is 4. If we write the value of 010, it is 2. And for 001, it is 1. So in this, we can see the maximum is 4, but this is not an odd number. So this is an even number. So we will not take this combination. 2 is also even number. So the only odd number is 1. So out of all the odd numbers, the maximum is this. So we have to return this combination. So we can see 001 is the answer. Let's take another example. So example 2 is 0, 1, 0, 1. So all the possible combinations of 0, 1, 0, 1 are this. And if we write the decimal value of 0011 is 3, 0101 is 5, 1001 is 9, 0110 is 6, 1010 is 10, and 1100 is 12. So we can see out of this, 3 is odd, 5 is odd, 9 is odd, 6 is even, 10 is even, 12 is even. So we will not consider these numbers. And out of all this, the maximum is this 9. So we have to return this combination. So answer of this will be 1001. So that's what the answer is. How we can approach this solution? So when we are converting the binary number into decimals, so how we convert that? If we see this chart, in this we can see this is 0th bit, first bit, second bit, third bit, fourth bit, like this. And for every bit, we are assign some weights to it. Like for 0 bit, the weight is 2 to the power 0, that is 0, 1. For first bit, the weight is 2 to the power 1, that is 2. Similarly, for fifth bit, the weight is 2 to the power 5. So, and the value is 32, like this. As we move towards left, the weight of a number at a particular bit position increases. So we can see at 0th bit, the weight was 1, and we are increasing the weights exponentially. So 1, 2, 4, 8, it is getting twice every time. So if we want to write the decimal of this number, how we can write it? So 1 is at the 0th position, 0 is at the first position, this one is at second position. So how we write the decimal value? If we see the second bit position, the weight is 4. So we write 4 into 1 plus the first bit position weight is 2. 2 into 0 plus 0th bit position weight is 1. 1 into 1. If we add it, we will get 4, 0, 1. So it is 5. Let, let's take this example also. This is 0th bit, first bit, second bit. So the weight at second bit is 4. So we will write 4 into 1. At first bit position, the weight is 2. We will write 2 into 0. At 0th position, the weight is 1. So 1 into 0. So in this way, we can see the decimal value of this number will be 4 plus 0 plus 0. That is 4. So in this, we can see whenever we are calculating the weight, we can see wherever the bit position value is 0, 0, it is not contributing anything in our final decimal value. We can see if we remove this, then also it is equal to 5. Similarly, in 100, we can see 100, we can see if we remove this bit position and this bit position, we can see these two bit positions are not contributing anything in this actual decimal number. So we can conclude from this, whenever there is any bit position value is 0, it will not contribute anything. And whenever there is the bit position as 1, it will contribute the value. So how much it contributes? It depends on the bit position at which the 1 is. In the suppose we have a number like 1, 1, 1, 1, 0, 0. If we ask how much this 1 is contributing in the total decimal number, we can say this is 0th bit, first bit, second bit, third bit, fourth bit, and this is fifth bit. So fifth bit means 32. That means this bit value will contribute 32 in the decimal number. So like this, if we ask you, if you have given, if you can use only one and any number of zeros, what is the maximum value we can create? So since we have seen 0 doesn't impact anything in our decimal number, so any number of zeros will not impact anything. But since we are using 1, so we have to use this one wisely. So where we have to put this one? Suppose we have so many bit position. If we put 1 at the 0th bit position, how much we will gain? So since the weight at 0th bit position is 1, if we multiply 1 with 1, we will maximum get 1. If we don't put this 1 here, and if we put 1 at the first bit position, the weight at first bit position is 2. So maximum we will get is 2. If we don't put this 1 at first bit, if we put this 1 at 0, 1, 2, 3, that means I put this 1 at third bit, that means the weight is 8. That means maximum we can achieve is 8. So we can see it totally depends on the weight of the bit position. So since the higher the weight, the more the value we will get. So if I ask, you can create a 32-bit number, 32-bit number, and you can use 1. So what is the maximum value you can get? So the higher the weight of that bit position, the more value we can get. So we will put this 1 at the beginning of the bit value, binary number. So if we put 1 here, we can see we can get weight of 2 to the power 31. That will be the maximum we can achieve. So this was with one number. Now, if I say you can use two ones and remaining as 0, so what is the maximum number we can get? Let me erase. Now, suppose we are allowed to create a 8-bit number, 4, 5, 6, 7, 8. Since we are allowed to use two ones, that means this is 0th position, 1 position, 2 position, 3 position. If we put 1 1 here and 1 1 here, how much we can get? At 0th position, the weight is 1, and second position, the weight is 2. If we add it, we will get 3. So, since it depends on the weight, we will try to achieve the maximum weight. So, if we put the 1 here, suppose if we move 1 1 here, at 7th bit position, we can see the weight is 128. So, 128, this bit will contribute 128 and this bit will contribute only 1. That means we can get a maximum 129. But what if we move this bit in with some higher weight? Suppose we move this bit at 6th position. At 6th position, the value is 64. That means maximum we can get is 128 plus 64. That is 192. So we can say the to achieve the maximum number, if we can rearrange the bits in such a way that we move all the ones at the higher position of the weights, we will get the maximum number. So this was the one condition to achieve the maximum number, but there is one more condition. So we have to get the odd number also. So for that, if I say, if we write the binary of 0 is 0, binary of 1 is 1, binary of 2 is 2, 1, 0, binary of 3 is 1, 1. Similarly, for 4 is 1, 0, 0. For 5 is 1, 0, 1. We can see when for a odd number at the MSB position, we can see we are putting 1. For 3, since 3 is also odd, we can see at the MSP, that is 0th bit position, we have 1. Similarly, for 5, we have 1. But for even number, at the 0th position, we have 0. See, we can, for 2 also, at this 0th position, we have 0. For 4 also, at the 0th position, we have 0. That means to achieve an odd number, we must have 1 at the 0th position. Then only we will get an odd number. So how we can get maximum as well as odd? So let's take this example. So to get odd, we have to put 1 1 at the 0th bit position, and to get maximum, we have to shift all the ones at the least significant bit. Sorry, most significant bit. So this is the most significant bit. So we have to move this ones to the most significant bit. If we take this example, so we can calculate how many zeros and ones we have. So in this example, we can see for 0, 1, 0, 1, the maximum number of zeros is 2 and the number of ones is 2. Since we have to rearrange this number in such a way that we get odd as well as maximum. Since we have already seen that for odd number, we must have 1 at the 0th bit position. So we have utilized 1, 1. Now we are left with 1, 1. And to achieve the maximum number, we should have all the ones at the most significant bit position. So if we have a 4-bit number, we must put this one. If we put that one in this bit position, we can see the maximum weight we will get, the maximum contribution of a number we can get is 2. CV2. If we put 1 here, we will get 4. If we put 1 here, we will get 8. That means if we put 1 at the most significant bit, we will get the maximum number. So the remaining one we will put at the most significant bit position, and we will fill up the remaining spaces with zeros. In this way, we will get the maximum number, odd number. So the value will be 9. So this is the answer. Let's take another example. In this also we can see we have number of zeros we have is 2 and number of ones we have 1. So since to achieve an odd number, we must use 1 1 at the 0th bit position. Now we are not left with any 1. So we can fill up the zeros at the remaining positions. That means we will get 0 0 1. So this is the maximum odd number we can get. So what we are basically doing. So first we can calculate the number of zeros we have, number of zeros and number of ones. And in the question, if you have read carefully, it has given that at least we will get 1 1. If they didn't mention this thing, then there might be a possibility that we are not able to create an odd number itself. That's why they have specifically mentioned that at least we will get 1 ones. At least we can create a single digit 1. So we will calculate the number of zeros, number of ones. We will fill the 1 at the 0th bit position, and the remaining ones starting from the MSB. We will put all the ones and fill the remaining spaces with zeros. In this way, we will get the maximum odd number. Let's try to code. So first we will calculate the length. Let's calculate the length. So length of the string is s dot length. Now number of zeros equal to 0, number of ones equal to 1. We will iterate the string, and if the character is 1, that means we have ones plus plus, else zeros plus plus. Now we have seen that we have to use 1 ones at the 0th bit position. That means at the s of length minus 1 bit position, we have to use 1 1. Now we have to reduce ones 1 time. Now for the remaining bit position, while we have ones, starting from the beginning, Let's initialize the position as I equal to 0. Starting from the beginning, we will put 1 once, we will decrement the counter, and we will increment the index. Once we have finished all the ones, we will fill the zeros. So while zeros, S of I will be zeros, zeros minus minus, and we will increment the index. Now we can return the string S. So what we have done here? So first we have calculated the length of the string. Given, take this example, length of the string is 4. Now, initially, I've made one mistake. Initially, ones is also 0. Number of ones we have taken a counter, which will keep the number of zeros we have, number of ones we have. So after iterating the string, in ones we will have 2, and in zeros also we will have 2. Since we have to utilize 1 once to fill up the 0th bit position, for this length of a string, the 0th bit position will be length minus 1 bit position. We have used 1 once here, and we have decrement the counter. Now, after that, for the remaining ones, we have started pushing the ones at, at the most significant bit position. So for a given string, if we have 4-bit position, 1 once we have utilized here, and we will start from the 0th index. We will start filling the ones from the 0th bit position. So we have initialized I with 0. While once we will fill the S with ones, and we will decrement the counter, and we will increment the index. And for the remaining position, we will fill the zeros. Then we will decrement the zeros counter, and we will increment the I. Let's try to submit. So we can see the test cases has been accepted. Let's try to submit the solution. So the solution is accepted. I hope the problem statement and the solution is clear. If you have any questions, mention in the comments below. Thank you.